Hello, everybody. Super excited to be kicking HasuraCon 2021 off. I will be talking about the future of application development and how I think about it as the desire to get data and get it immediately, right? As a quick introduction, I am Tanmai. I am the CEO at Hasura and one of the co-founders. I also head product. And with that, I shall dive in. So when we think about what we want, and by we, I mean, application developers or business teams, right? What we want is we want to be able to empower our developer team that is closest to the user because they will have the most amount of impact on our business. And one way of thinking about this, and that's kind of what I'm going to be talking about, is by making things self-serve, right? Making all of the parts of the stack as self-serve as possible. Now, this idea is not new, right? It is pretty much the central theme in the history of infrastructure and software evolution. Just to give you a few examples of what impact that self-serve has and where we've seen it before. When we think about the cloud, right, we went from this time when we used to build and operate a physical server to being able to rent and manage a VM in 60 seconds, right? To this point where we're now kind of doing things in a serverless way, right? We are at a place today where if you wanted to write an API that kind of took integers as input, summed them up, and returned a sum, right? That's easier than ever before, right? You can deploy to 1 million users, and that's possible. That's something that was almost impossible 10 years ago, right? To do within that time frame. When we think about databases, right, before databases came along, we used to read and write the files, and then databases and SQL kind of blew our minds. And in a sense, it was that kind of operation on data that became self-serve, right? And then we used to manage databases, and then databases as service came along, right? Whether it's cloud vendors or whether it's database vendors providing their solution as a cloud service. And suddenly we got to a place where we as application developers could kind of own our databases with a little more expertise that is required, but effectively we could kind of get that ownership, right? And cut out people and process in being able to do useful stuff with the database, right? And so databases are kind of also on this trajectory of becoming self-serve. Another place that we see this trend is with single-page apps, right? We came from a world where we were building and writing our user-facing application logic on the quote-unquote server, right? And then that kind of changed to single-page apps, right? Where we suddenly had this amazing amount of productivity in being able to own and write the application code, right? And for a lot of us, for example, when we think about that evolution, we think about Jamstack, right? Which is this ability to kind of almost build, operate, and deploy that user-facing application entirely by ourselves, right? Again, without needing other humans or processes. And that aspect is also becoming self-serve, right? As a general philosophy, right? I think to empower developers closest to the user, try to make as many things possible. Try to make as many things as self-serve as possible, right? When we think about this self-serviceness in the stack that we have today, right? We kind of are in this world where databases are becoming awesome day by day, right? And there's many different databases. There's many different types of databases storing different kinds of things, right? We know that our ability to kind of write code and deploying code and now even scaling code is great, right? One of the things that we see is, there's almost, it feels like sometimes there's a new JavaScript framework every day, which is actually amazing because it means that the ability to solve particular problems that different frameworks are optimized for is getting better and better, right? To deploy a different type of application, that experience is just amazing today, right? It wasn't possible a few years ago, right? But the piece that remains a bottleneck, that's kind of what I'm going to talk about, is the data access piece, right? If we're building these modern applications or services or whatever is user-facing ultimately, that piece where we're kind of connecting that application logic to our data, right? That piece is becoming and is kind of emerging as a bottleneck, right? Let me dive into that in a bit. So when we think about kind of connecting consumers who want data or who want domain data and domain logic, right? And we have producers of data, which is maybe in one or more data sources, databases, services. Typically, we kind of have to deploy that red box that you see in the middle, right? We need like a, maybe some parts of an API gateway, an application server, maybe something like an ORM, right? That has to talk to these sources. And humans, people, have to build that piece in the middle. And and of course, anything that is being built has process around it, and it becomes a bottleneck, right? And that's inevitable. It's not a good thing or a bad thing. It just does, right? And for a reason, which we talk about in the next few minutes, right? But when you kind of think about the impact of this bottleneck, right? If you think about, for example, you're working with new data, right? As an application developer, somebody has to understand my requirements, right? They have to understand my kind of present requirements, my future requirements, right? Like how I want to handle that trade-off, right? There's a lot of context that is in my mind as the person that's kind of trying to own the application experience for the end user. And I have to transfer that context to somebody else, right? So that they can kind of build that out for me, right? Or if you have existing data, one of the problems there is that there's just so much more data every single day, right? It's just exploding in the different places that it's in the different ways that it's created, right? And now that becomes another thing for this team that is kind of building, operating, and scaling that red piece in the middle to kind of start bringing that in from multiple places as well, right? So someone effectively has to build this. They have to operate it. They have to scale it. They have to secure it. They have to maintain it, right? And it feels like work there, right? And so if you take a step back, why can't we just access this data directly? Why can't we just let consumers get that data directly, right? What are the problems, right? I mean, there are reasons, and those are the reasons that I'll get into, right? So when we think about these reasons, they're legitimate reasons, right? One of the first reasons that you'll encounter, and this is kind of not in any order of priority, but just kind of in the way that we would encounter problems, right? The first is if you're kind of consuming this data, right? You're like, hey, the databases and the data sources don't speak my language, right? As a developer building modern applications, it almost seems like the de facto standard has become JSON and over HTTP, right? That's what I want to deal with. I do not want to deal with anything that's not JSON usually, and I don't want to talk over protocols that are not HTTP, right? As far as possible, right? You don't want to do that, right? Because everything is just built around it, right? And in this case, GraphQL becomes a really nice fit because it's kind of native to JSON, adds a few more capabilities on top of just that base JSON layer, right? And the default protocols are also over HTTP, right? Which makes it a nice fit to kind of speak that to kind of interact with data, right? And the Hasura point of view is also that, right? When we think about and when we thought about adding a GraphQL API as a supported API, right? We thought about this saying, well, how can we build a compiler like coherent abstraction, right, of taking these data concepts and moving them to GraphQL concepts and having that metadata in the middle that can kind of provide that help provide that kind of transformation, right? We'll get into what those pieces are in a bit, right? But that's one problem. That's a very valid reason why people typically have to build that, and hence that is a very valid thing that Hasura kind of needs to solve for, right? Another problem, which is what we talked about as well, is that data isn't just too many places, right? How do I discover where this data is and where it's coming from, right? How are all of these bases of data related, right? How do I consume it in a convenient way in a single shot, right? And technically, this is kind of like a federation problem, right? You want to federate the computation of fetching and operating on that data to these multiple places, right? You have a metadata problem, which is that you have to model your domain, which is a domain model, which is kind of constructed from these models being in different places, right? There's a discovery problem, which is that, okay, I know all of this is there. Now I need tooling to discover these models and the relationships between them. And then finally, to consume it conveniently, I need an API that works, right? And again, when we kind of think of these problems that need to be solved, the Hasura perspective is that what we want to do is we want to allow that data to be federated across those multiple sources of data. And we want to provide that metadata layer that can kind of model these relationships and connections between these models that exist, right, in these data sources. And the nice thing with GraphQL is that the GraphQL tooling and the community tooling handles a lot of the rest, right? And the rest in this case is, say, the discovery problem, the integration problem, the API problem. A lot of that is made very neat and kind of almost inbuilt by just having GraphQL, right? So that's kind of the way, that's again another problem that has to be solved at that layer that Hasura kind of takes care of, right? the two interesting talks that we'll be having in this conference today that will talk a little more about this is one, I'll be talking a little bit about our evolution of remote joins, which allows you to kind of join across sources. And Gavin will be talking about GraphQL type-safe clients, which is kind of another evolution that is happening in the GraphQL client ecosystem, right? And making that experience of integration usage better, right? From a API consumer point of view. The third problem in, again, automating that piece in the middle, right, is that there is untrusted code and there is a security context that we need to think about, right? So code that is running in the end user's context, it can't read and write data directly to our central data systems, right? I mean, obviously, you wouldn't want somebody that's accessing their own profile to be able to access other people's profiles and other people's private data, or if you're accessing a document, you want to make sure that you have the right ability to access or operate on that document, right? And this is, in a sense, the authorization problem, right? And that is another piece of the problem that really kind of needs to be solved well, to be able to think about making that piece as automated as possible, right? And again, when we think about this perspective, and we take this perspective in the context of the Hasura product, right? That's one of the reasons why we've built the authorization engine at the Hasura level, so that it can kind of model those application level authorization concepts, right? And then efficiently do the right things with the data as and when queries happen, right? This is also one of the reasons why, when we kind of took the most granular style of authorization possible, which is the, almost the RLS style in the database context, we kind of took a similar approach, but we built that at the application layer, right? And this effectively helps us provide, API security and model level authorization and role level authorization, right? API security ends up being, schema security in the GraphQL context, right? And so that kind of becomes an important, another important piece of that puzzle to kind of think about and automate or try to make self-serve, right? The fourth problem is that the code that we're writing, especially today, right, that's consuming this data, is increasingly stateless and concurrent, right? And for example, when you think about a mobile application or a web application, right, they're in a sense stateless because they're kind of, they have application state, but their interaction with the data systems are stateless. That means that they don't have a connection that's open 24/7, right? User logs in, does something, logs out, right? Each request or operation is stateless, right? It has no context apart from that operation itself. And it can also be heavily concurrent, right? You might have 100,000 concurrent users at the same time, 1 million concurrent users at the same time. And this is not just for applications, it could also be for modern services that we're writing, whether in containers or serverless functions or things deployed at the edge. These pieces of compute are also, quote unquote, stateless and concurrent, right? And databases, especially older databases, aren't great at handling that kind of stuff, right? Operationally, these databases like speaking in TCP, so that they can do a lot of optimization as queries are being sent back and forth, right? They need connection pooling. There is an element of topology discovery, fault tolerance, failover, load balancing, right? There's a bunch of things that need to happen at that layer, which makes this interaction stateful and less concurrent than what is suited for a modern application, right? And the Hasura perspective here, which is obvious for folks who've been using Hasura, right, is to try to HTTP all of the things that we can, right? And when we think about this, right, we think about 4 primitives, right, or 4 operations on that set of like polyglot data that we want to kind of bring into a stateless and a world that supports concurrency or high amounts of concurrency, right? And those 4 operations are querying, being able to read data, mutate, being able to kind of operate or change on data or create events to change data, right? Subscribe, which is that you want to kind of subscribe to changes that are happening in the set of data that you have, and notify, which is that whenever data changes, you want a notification to go up, right? And these kind of map to concepts that you would see in Hasura, right? You see queries, mutations, subscriptions, event triggers, right? Actions, right? They all kind of fit into that idea of saying, how can we provide an HTTP abstraction over these things that allows developers to kind of move fast and not deal with operationally useless stuff. I don't want to use the word useless, but operationally inconvenient stuff, right? You don't want to deal with it, right? The fifth problem, again, in this theme of trying to make things self-serve, and why humans have traditionally kind of been building and maintaining that layer by hand, and why it's critical, right? And why that role seems to be critical is because databases are central sources of truth, right, for the domain, and they're pretty critical, right? That's kind of the data, and the way that we look at that data and the way that we operate on that data is essentially what the organization is, or what any business or product is, right? And databases hence become critical points of failure, right? For example, you can't just take that data system and expose it to people, because in case there are complex queries or too many users, this central system might get overloaded, right, and might crash, right? Or for another example, they might become easy targets for denial of service attacks, because that is kind of the most central and critical piece. Let's just do stuff to make it fall over, right? Or in a kind of more active attack vector would be to kind of just exfiltrate data, right, or to muck around with the data that is there in that central source of truth, right? And the Hasura point of view here is to say that, can we provide the flexibility of being able to get that self-service access to data, but at the same time protecting ourselves very clearly against the fact that these databases are one of the most important things in our organization, in our stack, right? And two things, for example, are, one, that we want to make sure that we're able to deal with performance as a built-in thing, right? And that's kind of why we have this insane amount of focus on just trying to build in performance at every step, but also why, for example, we're investing heavily into things like caching and private data caching and automatic discovery of cache keys and things like that, right? Another example is of things that we're working on is to make sure that if there's any accidental or deliberate abuse of this kind of flexible API to access your data, you're able to prevent that and control that, so that this central critical system, things don't happen to it, right? And two talks that you'll see during the conference are Phil's talk on what we're doing with caching, a few patterns of how to use it and stuff that we're working on. And Thiru will be talking a little bit about GraphQL and security, both in kind of a generic sense of how to think about security with GraphQL, and also stuff that we're working on at Hasura to alleviate some of these problems, right? The sixth problem, and one of the last problem, is that stuff changes and the domain evolves, right? And so we often want a layer of abstraction in the middle that can protect against that rapid evolution, right? And what we effectively want to do is to get to a place where our data models and our domain logic and our domain models can keep changing and evolving. And at the same time, we should be able to evolve our API without breaking, right? That's the dream state of where we want to get to, right? And that's the reason why you have humans and building layers of technology to try to ensure that, right? In some cases, the API is not just being used by an application, but in a sense, the API is the user-facing application, right? The API is the product. That controlled API is what you want to provide as a product. It's not an application, right? And our perspective, when we think about that at Hasura, is to make sure that the data model is easy to evolve, right? So I'll be talking about a few things that we're doing here to make sure that this evolution can be as easy as possible, right? Whether it's making sure that tables and views are compatible, right, and are replaceable with each other, or whether it's kind of making sure that we're able to kind of switch out at any point of time to a stored query that we can run, right, that can be parameterized and things like that, right? One of the other ideas here is that, in a way, when we think about, if we think about the API as being the product, then maybe that API management, right, piece can move out of the data access piece, right? Which means that, let's say, for example, I need to build an API, a very controlled API that exposes just 10 very precise endpoints, right? It's 10 very precise operations, very precise pieces of data that can be fetched, right? Let's say that's our product, right? In this case, one of the potential ways of building with Hasura, right, and the way we think about it is the introduction that we did with introducing REST, the ability to restify GraphQL queries. So you kind of use Hasura and the GraphQL portion to shape that perfect query or that perfect operation that you want and convert that into a controlled REST endpoint, right? And now this REST endpoint allows you the flexibility to make sure that the data shape is the same while other stuff behind it might change, right? And we're kind of making steps in that direction. Another way to think about it, which is very interesting, is to think about our application, right? The API is our application. So to think of it as entire pieces of entirely kind of stateless code that we deploy as close to the edge as possible, the edge of our application, right? The front portion of our application, as close to that as possible. So let's say, for example, we use serverless functions or workers, on a CDN, right? Or on an edge network to actually front the API, right? And the nice thing here is that these workers can remain entirely stateless. They don't have to worry about performance. All they care about is the API contract that they maintain, right? Which is the application that they're maintaining, while the rest of the data access problems are still solved, right? So as an application developer, almost what I'm trying to say is that we build these applications which the users are using, which can have a UX, right? Or we're building applications where the UX is essentially an API, right? And in both of those cases, the rest of the problems remain the same while we're focusing our energy and kind of building what is most important to our user, right? I'm doing a talk today talking about kind of an architect's guide to building with Hasura, which takes a lot of these concepts and these problems that we discussed and presents a mental model on how to think about these concepts with Hasura and how to think about incrementally using Hasura to solve some of these problems and try to make kind of data access more and more self-serve, right? And so that will be happening, I think it's 4th of its talk today. So we'll talk about that in a bit. Cool. So now I'm going to talk about a few reasons that I don't think are valid anymore, but are almost legacy artifacts in our ways of thinking, right? It's legacy ways of thinking, right? So let's talk about one example, which you'll hear sometimes, and hopefully you've not heard of this, but sometimes you'll hear the sentiment being echoed, right? Which is that application developers don't have the expertise to deal with data. So that's kind of why we don't want them to have direct access. Even if we solve all our technical problems, we don't want them to have direct access to our data systems, right? I don't agree with this at all, right? There are two reasons. The first is that applications that are user-facing are actually becoming more and more complex. They're becoming extremely rich, right? Because we have several ways of deploying it, right? Whether it's a web application or a mobile application or whether it's an IoT thing. And in the future, 5-10 years from now, there's going to be, say, AR or applications everywhere, right? These are complex applications, right? They still might need a central data store for the product to work, right? But that doesn't, and those technical problems need to be solved, but those applications are really complicated, right? And application state, right, at the end user is also becoming increasingly complicated to handle. Now, having this kind of mentality that historically server-side stuff was complicated and application stuff is not complicated, that using that sentiment to justify and to say that that's the reason why we don't even want to think about making data access self-serve, that's not okay. That's bad gatekeeping, right? That's not a cool thing to do, right? The second thing, and which is why people had this sentiment, and this could have been a valid sentiment many years ago, is that databases and data workflows were starting to get very complicated, right? And requirements were becoming like super niche. For example, we had so many different types of data. We needed to do distributed transactions as applications started scaling out, right? We needed geo-distribution in case we had multiple geographies, right? We have time series data, for example, which has its kind of own peculiarity in the way that data is operated on and accessed and aggregated and stuff like that. If you want to do online analytics at scale, which is where we see so many of the data products in the ecosystem kind of evolving around, right? That piece is getting complicated. And what would happen is because those requirements were getting so complicated in the way that we dealt with our data, is that we needed this layer in the middle to deal with that gap, right? We could not do distributed transactions on a single node RDBMS, right? It was not possible. So we had to bring that logic into this middle tier so that we could tide that over, right? But today, and especially over the last 5 years, today we see that there's an incredible amount of work that's happened in the database industry, and this hangover that we've had from a decade or two ago is no longer valid, right? Two talks that we'll be seeing at the conference, one from the folks at Yogabyte who effectively helped build kind of a distributed database, right, which speaks Postgres and solves some of these hard challenges around distributing and scaling a database that just works really well with Hasura, right? And so that means a lot of these kind of problems that we assumed would be things that we would encounter at this middle application tier are no longer problems that we will have in the future, right? And I'm super excited for this talk, especially because we're also going to be working closely together, and there's a partnership that we'll be having between Hasura Cloud and Yogabyte Cloud as one of our first partners in the distributed database ecosystem to kind of make that experience really, really nice, right? Another great talk that we have today is from the timescale folks, right? And where Untrusted will be talking about using Hasura with timescale for a time series workload inside timescale, which is a little bit of an inception thing there, right? But again, here we're talking about use cases where the kinds of data that we're dealing with or the applications that we're dealing with are complex and are evolving, but it's being handled by the database, right? That's the new world that we're living in. Another problem and another legacy style of thinking to think about is that bugs me, right? Is when we say all details should be hidden from developers, right? And just a way of thinking that application developers shouldn't see details. We should hide all details, just hide details, right? Which is not a way of thinking that I think we need to have as we move towards the future, right? I prefer a way of thinking where we think about how do we empower people in a way that they can be self-serve, right? And they can just do what they need to do, but we can still maintain those constraints around performance and security and those hard technical process challenges that we had, but automate them, right? So that we can empower our developers instead of hiding things from them to empower them and make them productive, right? It's almost a political stance in some sense, right? One of the things that I think is important to think about here, right, is that whenever we think about quote unquote details, right, some details, technical details or security details or domain details, right, someone has to pay the price, right? So someone has to understand those details and fix them, or some technology has to understand those details and fix it. They're not going away. They're important details, right? They need to be tackled. Somebody needs to do it, no matter what you do, right? When we talked about these technical challenges, which we talked about, which need to be solved, those details are things that we can start to automate, right? And remove people and remove processes from that kind of middle bottleneck layer, right? But when we think about kind of the human challenges, right, behind these details, this idea of saying that we hide stuff from application developers to empower them, because that's just how we've been building applications, that's not cool, right? That's not okay, because even conceptually, somebody has to do the work, right? The people who are the humans who are thinking about those details, or the application developers, if we offload those details to them, somebody has to do the work, right? We might as well try to push the work to the people who have the most amount of agency in being able to do something with it, right? And again, when we go back to the history of the cloud, databases, compute, application frameworks, that's kind of the trend that we see, right? When we introduce databases as a service, as a developer, I now have to worry a little bit about a database, right? But I don't need a human in a process as much as I did before to maintain that database, right? So I still pay the price of having to understand this database and the way it works, but I get agency and I get empowered in being able to do something with it, right? And that's the trade-off that I think we increasingly need to think about, right? Do we hide these details to try to make people more productive, or do we empower people to make them more productive, right? And so that's kind of another cultural kind of legacy cultural reason that I think about, right? In that spirit, we have a few announcements in the spirit of empowering people and making data access self-serve. at the conference today. So the first is a release of cross-database joins, which I am so stoked about. It sets the foundation for being able to generalize remote joins entirely. It's as easy as specifying a relationship within a database, but now it's across databases. I'll be covering some aspects of that in my talk today on the evolution of remote joins. The second piece is schema sharing, which is this ability to package together a piece of the database schema and the Hasura metadata, one or both, and that module can then be loaded up by a developer using Hasura, right? And that makes onboarding super easy. That makes sharing and documenting patterns and best practices super easy, right? Again, in kind of that culture of being able to kind of share that knowledge and empower each other with some of these techniques and things that we're all kind of learning together, right? And that's something that Martin will be talking about later today as well. The third is preview apps and GitHub integration, which is something that we've been working on to make sure that we can kind of do an instant deploy of GitHub onto Hasura Cloud. And we'll also do a demo of how you can use that to build an end-to-end preview app per PR kind of system, right? That every time you have a pull request, a small change, you get a Hasura application for that preview app that you can try out, test, stuff like that. And Rishi will be talking about that later as well. And so please do join in for all of these announcements and all of these other amazing talks that we have at the conference, talking about a lot of the themes that hopefully I set context for, and some extremely exciting user stories of different kinds of ways of using Hasura and realizing productivity with Hasura. With that, let's have a great conference, and thank you so much for being here, and enjoy the next 2 days.
So Tanmai, I was telling Rajoshi as we were talking at the beginning that I hadn't had a chance to preview those slides yet. And wow, that was awesome. I'm so stoked that you did that for us. And by the way, just as a bit of advice, I am totally going to use the phrase, the problem is that stuff changes at least once or twice when we're talking to each other in the future. For those of you who are watching, the Q&A pane is to the right. There's a couple of questions in there. We actually have about 15 minutes with Tanmai to answer some Q&A. So I'm going to start working through those questions. If you have questions, of course, as we talked about earlier, there'll be deeper dives into a number of the features coming up. But as you have questions, please feel free to drop them in the Q&A. So we'll start at the top if you're cool with that, Tanmai, and work our way down. The first question for posterity is, you mentioned the problems of data discovery and metadata management. Hasura knows a lot about the metadata, relationships, et cetera. Are there thoughts on building like a data catalog or a data dictionary or an ERD, et cetera?
100%, right? And that's when we think the heart and soul of Hasura is the metadata that it has, right? Which is kind of gathering all of this information from the upstream systems and that the domain context that the developers are kind of configuring Hasura with, right? And that plays such a vital role in every single thing that Hasura does, right? Whether it's GraphQL compilation, whether it's the authorization policy, whether it's optimizing, doing static analysis of authorization policies, and like your the queries that are being sent or caching, right? So all of these things are kind of dependent on that metadata. But like the question kind of came, right? Which is a perfect question, right? Which is that we have all this information. We can do so much more with it to solve kind of more human and process problems as well, which is essentially the metadata problem, right? So while you're building with Hasura, you're essentially doing all of those things that actually are required to solve the metadata problem. You are in fact building a data dictionary. You are adding comments and talking about what these models are. You are setting up semantic relationships between those models, right? You are you're specifying kind of the right way to query things, right? You're pulling information for what columns are indexed, what is not indexed, what's a good way to query, right? All of those things. And so extending Hasura to kind of build metadata features on top of that is something that we think about a lot, right? In fact, Gavin and I and a bunch of us worked on an early version of kind of a build your own data dictionary toolkit, right? And so that's let me just pop that in the chat. So Hasura data dictionary, if you Google for that, yep, there you go. I'm just going to drop that in the chat. That is that's kind of a toolkit that basically picks up off the that takes the Hasura metadata, right? And Hasura itself has APIs for upstream metadata also. And it kind of takes that, combines that, and provides the necessary APIs for you to kind of build your own data dictionary using Hasura's metadata, right? So you can kind of use that dictionary and say, all right, for this particular role, what are the models I have access to, right? And then what are these models actually physically on the data system like, right? Which ones are indexed, which ones are unique, stuff like that. So we already have the APIs to do this. The metadata is a huge part of what Hasura is. And we'll gradually kind of start building a lot more tooling around it so that the community and us along with the community can start kind of building these features on top of metadata. And eventually we'll start integrating these features into Hasura itself. So that's kind of the long answer.
I think as someone who is, who was at one point relatively new to Hasura, the value inherent in metadata wasn't like directly obvious to me until I started playing with it and building things. And I'm like, oh, look, the heart of my system lies there. And that's it's exciting, even as a member of Team Hasura, to look at what we can do and what we're thinking about in the future. So the next one down on the list is, share what you're comfortable with, but what is the largest concurrent request that you know of that's been done?
With Hasura, I think at scale, we've worked with people who've had between 200K to 500K concurrent at a time. And that's kind of Hasura scaling out. On our systems, I think we've benchmarked to be able to go to like a few million really easily. So it should not be a problem. The good thing is Hasura is stateless. So very frequently the concurrency kind of bottleneck is not going to be at Hasura. It's going to be an upstream systems, right? So Hasura itself, scales vertically and horizontally really well, right? So you have kind of near linear performance if you vertically scale up to the number of concurrent users that you can add. And then of course you can kind of keep scaling out as well. So that kind of makes our ability to handle concurrent loads quite easy or quite straightforward.
Nice. So this next question is a bit of a shift, but it is fair to answer. There's a talk coming up called "The Architects Thinking How to Think Hasura" or "An Architect's Guide to Hasura." But the question is about, you were talking about the notion of the monolith and how our industry has gone through a trend of how we tend to build things. And the question I think is, how do we ensure large apps don't have to create the new monolith via everything connected in GraphQL?
Yep. That's a really good question, right? And so I think, the short answer quickly before I go into the long answer, right? So the short answer is that Hasura is kind of the API, and the API is monolithic. Right? Because it's a single point of entry into kind of your data mesh of sorts, right? It's like it's a bunch of things that you have. You have data and logic running around and in different places, wherever they are, but unifying them and that single point of entry, that is Hasura, right? And this is the reason why Hasura doesn't run too much logic inside Hasura, right? Like we've been asked so many times, right? Let's have a way of writing code inside Hasura that would make so many things easy, right? And we've stayed away from that because we're like, if as soon as we do that, right, this starts becoming the next generation monolith, right? Because now you're running user code inside. It's not declarative anymore, right?
Right. Yeah.
So the GraphQL API is a monolithic API and a monolithic view to what might be what might be a monolith, microservices, serverless functions, an entire mesh of data and services, right, that is running internally. That doesn't matter, right? And what you're doing at Hasura, right, which is that metadata layer, that is kind of the bare minimum that you need to provide that monolithic API. Everything else is still yours. So the data is still yours. So whether your data is in one monolithic database, a monolithic database that is a distributed database, or a bunch of different databases, that's totally up to you, right? That doesn't change. That architecture doesn't change because of Hasura, right? Whether you're writing things in containers or serverless functions or a monolithic Java app, doesn't matter. That part of the business logic is still yours, right? And we don't want to enforce or change things there. because that entire ecosystem is evolving so quickly, right? So the API view is monolithic. Nothing else is monolithic, right? Or has to be monolithic.
Right. I think that's a good way to say it, right? Nothing else has to be monolithic because, as we talked about a minute ago, the problem is that stuff changes, right? So I think that this sort of combined question came in before your last slide, but in the sake of completionism, I'm going to bring it up anyway. Hey, is there any simpler way for CI/CD with Hasura and adding on to that, like without breaking other pieces that are in the front end?
So I think that's already, that's already what Hasura does, which is that you can kind of keep adding stuff to Hasura and the front end won't break. So that shouldn't happen. When it kind of comes to some of those CI/CD aspects of rolling out changes, right, and change management, there's a bunch of stuff that we've been working on, especially on Hasura Cloud, because on Hasura Cloud we have there's a lot of automation that we can build in with the query history that's kind of coming in and the metadata that people have, right, to do some analysis to tell you whether there is kind of, for example, going to be a regression based on your query history that might break, right? Or for example, based on your query history, we released in 2.2 a bug fix that might have a breaking behavior. So you have to remember to toggle that flag on, and then later on, go in and change that syntax so that it's not buggy anymore, right? Things like that. So a lot of that becomes easier. Underneath it, Hasura has the tooling and is emitting that information to make sure that the change doesn't happen. But a part of it is a process problem to make sure that things don't change. That when things change, everybody else is keeping up, and it doesn't break things. But that said, there's a lot of tooling in Hasura and in the GraphQL community itself to ensure that as you evolve the GraphQL API, the GraphQL API is not changing in a breaking way.
Yeah, it makes sense. I think that follows, and some of the work we're talking about later on today even is steps in the direction of making that even easier. Just a very sort of specific question: is there any considerations for the future where Hasura can be available as a managed service within other clouds like Azure, AWS?
Yeah. So we have for folks who are using, say, our cloud enterprise plan, right? We already do. We work in a dedicated VPC with VPC peering, or we set up the data plane running as a managed service, like a managed data plane that is running in the customer's VPC. So that's something that we already do. It's a managed, basically your data plane, like the GraphQL API is a managed service running in your infrastructure, running on your AWS, your Azure, your Google Cloud. So that's something we've already started doing. And of course, if you're interested, please do get in touch with us. Would love to kind of have our team take you over it, and then of course see if that that's a good fit for you.
So we're not going to be able to get to all the questions because we do have to keep moving forward. But one last quick one, and then for those of you who've asked so many questions, thank you. Members of the Hasura team are either in the Hasura booth if you want to reach out there, or I'll ask people to start answering them directly in chat and just copying and pasting the question over so that everyone can see it. At least then it's a public conversation versus a private one. So the last sort of very specific question, when are you planning to add support for custom scalar and opaque types, like an order ID scalar type instead of big int?
Yep. There's a lot of requests that we've seen and that we really want to get to around type customization. Recently there was an issue. There's been a popular issue that folks have had where you want to kind of map that UUID type that Hasura has with a Postgres scalar into something like a GraphQL ID type, right? Or the question that came in, which is that you want to have big into order ID, right? That's something that we now have the foundation for. We wanted to make sure that the foundation for supporting multiple databases is in place, and now we can kind of basically start churning those out. They're really simple to do, but it needs to be kind of done on that foundation of making sure we can connect to multiple sources. So now that we have that in place, a lot of this is going to kind of get done super quickly.
Awesome. Tanmai, thank you so much, not only for pulling that together for the talks that are coming later in the day, but for taking time to answer Q&A with us. And we'll hop on the rest in chat and get members of Team Hasura to help out. So Tanmai, thank you. We really appreciate it.
Absolutely. And see you folks in a bit. Bye.